So find an equation of a line that passes through its points from there. Give your answer in the form ax plus by equals c. This caused a lot of issues for many people, the final part at least. The first part should not have. Okay, the first part should not have. So to find any equation, what are the two things we need to find? Gradient and y-intercept. So we've been given two coordinates. How do we find the gradient when we've been given two coordinates?
2 minus y, 2 minus y.
Alright. Okay. y2 minus y1 over x2 minus x1. So remember the change in y over the change in x. Doesn't matter which one's 1 and 2. What numbers am I going to use then?
2 minus 5 and 1 plus 3.
Okay, so I don't know who it is, so I'm not picking on you. I know at least one person did switch coordinates. So they started with this coordinate for the y, and then they started with this coordinate with the x. It's really important. I don't need to know you guys. It's really important that you don't do that because that's going to change. It's going to mess it all up. Okay, so 2 subtract 5 is
Minus 3.
4, and 1 subtract negative 3 gives us 4. So we have a gradient of negative 3/4. So y equals negative 3/4 x plus c. So you'll notice we've been doing the same thing each time we've been trying to find the equation in the straight line. What do we do now?
Find C.
Find C. How do we do that, Laura?
We substitute.
Substitute what?
Either A or B.
Okay, so we're going to substitute out one of our sets of coordinates here. Which one would you like to substitute?
First one.
Alright, so unfortunately we're using negative 3/4, so neither are super easy, but more people shouted the first one, so I'm going with the first one. So 5 equals negative. What's happening to these two values? They are being multiplied, not added. Okay, so we've got 5 equals, remember, negative 3 means negative 3 over 1. You had your calculators available to you. You could have chucked it in there if you were unsure. Negative 3 multiplied by negative 3 is? Positive 9 over 4. Okay, so far so good. Now, admittedly, these are not nice numbers, but just said it. You had your calcs, you could have used them. If we're talking about this denominator being 4, I could change this one to have a denominator of 4. At the moment it has a denominator of 1. So I could multiply both top and bottom by 4. Agreed? So this would be 20 over 4. And now I need to subtract 9/4 to get C on its own. So I've got 20 over 4, subtract 9 over 4 gives me 11 over 4. Okay? 20 subtract 9 gives me 11 over 4. So I now find the equation of my line as negative 3/4 x plus 11 over 4. Now, normally we would be able to stop there and say, well done us, we've finished. But for this one, they've said we have to give it in the form ax plus by equals c, where a, b, and c are what? What's an integer?
Whole number.
Tell me something.
A whole number.
It's a whole number. Are these whole numbers? No. So, we did do a few of these. What's the easiest way of getting rid of fractions? Yeah. So, we're gonna multiply everything here by 4, because that will enable us to get rid of our denominator. So we're going to multiply everything by 4. So we've got 4y equals negative 3x plus 11. So, much better now, they are integers, but they're not in the order that they've asked them for. Oh, so they want the x, then the y equals the value. So, remember I said ideally we would like the value in front of the x to be positive. I wouldn't have marked it wrong if you had left it negative. But ideally we would then add 3x to both sides, so we would have 3x plus 4y equals 11. Now, as I said, you could have had negative 3x minus 4y equals negative 11, because those numbers are also integers, they're whole numbers. but this is the slightly nicer format. Okay? Next one. Line L1 has the equation blah blah. Line 2 has the equation blah blah. Show that it's perpendicular. Okay, so we have to show that they're perpendicular. What feature of a graph do we need to establish to talk about perpendicular lines? The gradient. So we need to establish the gradient. So L1 has a gradient of no. L1 has a gradient of no, just 3.
Oh.
Okay. I'm getting pedantic, but the gradient is just 3. Okay. How do we find the gradient of L2? Can we do it just by looking at it? No, I would suggest we're going to have to do some rearranging. Yes? So for L2, at the moment I've got 6y plus 2x equals 1. I need to start rearranging this baby to get y equals. So I've got 6y equals negative 2x plus 1. What do we do then to get just y? So I have to rearrange this because in order to establish the gradient of the y-intercept, it has to be in the form y equals mx plus c. So I'm taking away 2x from both sides. You can put it in front. I've just kept it in the order that I've used to. Okay. What do I now have to do? Divide by 6. Remember at this stage, when we're doing straight line graphs, this is where I would normally suggest you divide them separately. And then you've got negative 2 over 6. Can that simplify?
Yeah.
Yes, to give negative 1/3. So my gradient of L2 is negative 1/3. So this is where we have to actually answer the question. And I know some people stop there and went to check me out. I'm awesome, I've done it. But it does say show it's perpendicular, so you need to make a statement. So you do need to say, since this is 3 and this is its negative reciprocal, you have shown that they are perpendicular. Something of that nature. I'm not going to write it down. You need to just have some kind of word to state why they are perpendicular.
Oh, so you didn't have to swap around L1?
No, because it was already in the form y equals mx plus c. Okay, so we knew they were perpendicular, we just had to show it. Alright, next one. Oh, that's another next one. Alright, so draw the graph y equals 4x plus 2 from negative 1 to 3. Different. Something like, because the gradients are negative reciprocals of each other, they would be perpendicular.
Wait, can I see? This is what I
Alright, so this one here, you've got options. Remember, at any stage you can draw yourself a table of values. Lauren? You can draw yourself a table of values and plot points. At least one person found the points but just didn't plot them. The issue here, people were not looking carefully. This scale goes up in 2s. This scale, 2 squares represents 1. So that was causing a big issue when it came to drawing your straight line graphs. I did try and stress it several times when I was teaching it. You have to look at the axis scale. So, ideally, however, I would have loved you to have recognized that your y-intercept was going to be positive 2. So I gave you 1 mark if you actually went through the y-axis at 2. And what's our gradient for this line? 4. Remember, gradients we want to think of as a fraction, so we want a rise over a run. So from that point 2, we're going up 4 units, not 4 squares, 4 units, so that's up to here. And going across 1 unit.
Oh.
Going up 4 units. That's what I said. So remember, the first option was that you substitute values in and you plot them as coordinates, or you could have used this method. Either way, you need to be looking at where you're plotting your points. Several people were plotting things along this line, along this line, along this line. I don't know what those values are. Okay? So you've got to be really careful when you're doing that. And then after you use your ruler to extend it. What's the matter? any straight line that's parallel to that. A straight line, any. You could have, every single one of you could have had different answers. Y equals 4x plus minus anything. I did not accept plus C. Okay, so I did not accept plus C. You had to choose a number. Okay, because that's not an equation. No. Okay, it had to be, you could have left it as 4x. 1 set to 0. Yes? So you could have just left it like that, but you couldn't have plus C. Write down the gradient of a straight line that's perpendicular. They just want the gradient. They don't care about anything else. They just want the gradient. What would the gradient be of a perpendicular line?
Minus 1/4.
Negative 1/4. Awesome.
That's it.
All right. Here we go. Here's a new diagram. We've been told the coordinates of these points. Okay. Find the midpoint of CB. So we've talked about midpoint. CB. So we're talking about. Oh, shush now. We're talking about these two coordinates. We're finding the midpoint of them. So how do we find the midpoint, Natanya?
X1 plus X2 over 2, comma, Y2 plus Y1. Oh, well,
Doesn't matter the order.
over 2.
Okay. It doesn't matter the order here because you're adding them. Okay. So if you were doing some subtraction, then it would matter, but when you're adding them, it doesn't. So we're adding our two x values. So 5 plus 0 over 2 and 4 plus negative 1 over 2, and simplify that. So 5 plus 0 is 5 divided by 2. You can leave it as an improper fraction if you wish, or you can leave it as 2.5. 4 plus negative 1 is 3. Okay, so you've either got 5 over 2, 3 over 2, or 2.5, 1.5. Find the length of the line AB. This time it's talking AB, so you've got to be careful here. Pythagoras is 0. Remember, we're trying to find the difference between the x values and the difference between the y's and square rooting it. And so you've got AB squared is going to be negative 2 take away 0 squared plus 0 take away 4 squared. Negative 2 take away nothing is negative 2. Squaring that gives me 4. 0 take away 4 is negative 4. Squaring that gives 16. So AB squared is the square root of 4 plus 16. Oh, no, shut up, Sarah, square root there. Is 4 plus 16. So AB is going to be the square root of 20. You could have left it as the square root of 20. Is that what I'm supposed to do? I don't remember that being the answer.
0 was 2 for 5.
Yeah, that was mine.
No? Okay. Is the triangle ABC isosceles? What is an isosceles? What features of an isosceles triangle?
Two sides of the same.
Two sides are the same and one is different. Okay? Now, for this to be shown, you have to find the length of all three sides. You can't just stick to 2 and say, oh, there you go. So we've already found AB, so we need to now find BC, and we need to find CA, or AC, same thing as gradient. We're using the same formula. We have to do it all again. Should we just say what they are? I'm not. You can work this out.
AC is factor 2. So BC is factor 2, and then AB is factor 5.
See this? So something's gone wrong here. What's gone wrong here?
It's 4.47.
Is it?
Yeah.
Alright, okay, shut this
It's
down.
4.47.
Alright, so we've got BC is 5 root 2, CA is 5 root 2, and AB is root 20. Are all three of them the same?
No.
Are two of them the same?
Yes.
Okay, so since two lengths are the same, and one different, it is isosceles. Okay, something of that nature. Okay, the showing you're working needs to show that you've got all three side lengths.
If you like put the wrong reason, but you put like, yes, it is an substance, you get a one.
No, because that's taking your bets. You've got 50-50 chance. Okay, so you will find that in an exam situation, that's why it says show your working. Because someone could say, I don't know, let's just say it is, and go, oh, great, I've got marks, but it's just because it's a guess. Okay? Next one, the rhombus. What's the features of a rhombus? What do we know about rhombus?
Two pair of.
Do we know what rhombus is?
Same length.
Pardon?
All the sides
It's
the same
All
length.
the sides are the same length. So
It's a
basically, it's just a tilted square. So find the length of DC. So they haven't told us anything about coordinates D and Z. Okay? But we know that this would be the same length as this, correct? Well, it's a horizontal line, P. What's the coordinates of A?
7 to 1.
7. Okay, so this point here would be 7, and this would be 11. And then this point here would be 17, and that's also 11. So what would the length of this line be? 10. Yes? Do you all see that? So Hannah, did you see what I did?
Oh, that makes so much sense. Wow.
So, coordinate A is 7, 11. So I've just shown it on the diagram. 7, 11. And B is 17, 11. You're happy that these two are equal to each other, yes? And so the distance here must be 10 units. Okay? So if we weren't looking for anything any crazy Pythagoras stuff, you could use Pythagoras.
Maybe 0 and 10.
You could have used Pythagoras' theorem, you just would have been making life hard for yourself, because it's a horizontal line.
I got that right, but now I know who.
I can have a look afterwards.
To find length of the line.
Because length of the line is using Pythagoras, but because the difference in the y is 0, you're just adding a 0. I'll show you. Hey, girls, I'm losing some of you, and this is why I'm going to test with everyone. Right, find the gradient of the line AB. How do you find the gradient of the line? Rise over 1. Can you look at it and tell me what the gradient is?
0.
Why is it 0?
Because it's horizontal.
It's horizontal, there's no rise. Also, all of these answers are correct, and then you work 1 mark. Circle the equation of the x-axis. Something you need to learn, I did say it numerous times. It's y equals 0. It's a horizontal line, so it has a y equals equation. Oh, P has for blah, Q has for blah. Find the equation of the line PQ. Equation of line, oh my good lord. Equation of line, what format? What two things do we need to find?
The gradient is the y.
A gradient and a y-intercept. How do we find the gradient?
Right around.
Right over around, we've got our coordinates. So we've got a rise of 1 take away negative 1. And our run is 4 take away 0. 1 take away negative 1 is 2. Our run is 4, which gives 1/2.
Wait.
Can you just say 2? I mean 2. 2 over 4 is not. So,
I said 2 over 4 equals 2.
So we've got y equals, ladies, please, 1/2 x plus c. Ideally, again, you're told that the p has coordinates 0, negative 1, so you should ideally be recognizing that that's going to be your y-intercept of negative 1. If not, you could substitute the values in. So it's y equals 1/2 x take away 1. P and Q are two vertices of rectangle PQRS. Find the equation of QR. Okay? So it doesn't really matter where R is. But what would the relationship? So if I pretend that R is up here, what do I know about this part and this part? They're perpendicular, yes? So if I knew the gradient of this, we just worked it out to be 1/2. What would the gradient of this line be?
Okay.
Emily?
Right, it would be.
Sorry. But I have a question. Oh, so what does FT mean? Follow through. So you made a mistake, but I carried it.
Okay.
You had the wrong gradient here, I think, but you used that gradient. Yeah. So if we had a gradient, so you can answer it now. If you had a gradient of 1/2, which is what it should have been here, so it will be a gradient of -2. So again, the equation starts y equals -2x plus c. We don't know point R, but we do know it has to go through point Q. So we know the coordinates of point Q. So we would substitute those values in. So we would substitute 4 and 1. So we've got, is it 1 equals -2?
Wait, why would you do 4 and 1?
Because it's the line QR. And we don't know any coordinates for R. So if it's the line QR, it has to go through that point. So we've got 4 equals -8 plus c. C ends up being 12. So it's y equals -2x plus 12.
Wow.
But then, because it doesn't